Hi, this is Mrs. Kidman, and in this video, we are going to be discussing the difference between linear, exponential, and quadratic functions. So just as a quick review over these different things, here are some images of a linear function, an exponential function, and a quadratic function. So a linear function is kind of what it sounds like. A linear function, when it's graphed, it creates this line here. And when we write these linear functions, we usually write them in this form that we call slope-intercept form. And the reason why we call that is because our m here represents our slope, and our b here represents our intercept. And so slope-intercept form uses our intercept on our y-axis and our slope to account for our linear function. Awesome. We use an idea kind of like this for all of these other ones as well. So in an exponential function is a function that increases by a specific rate that it's being multiplied by. So every number before it is 2 times or 3 times or half the number of times as the number previous to it when we're looking at our y values. And we usually write this one in the form y equals a times b to the x power. And what these are is very similar to our slope-intercept form. This is what's happening here. Our a is going to be our y-intercept. So where does it cross our y-axis? In this case, it looks like it could be about a 2, so we'd have a 2. And then this b tells us how much of a growth or a decay do we have? What's our exponential that we're looking at here? And so this is going to be the difference in our y values. And that difference in y values is going to be multiplied. So it's going to be either like the number before it is 3 times smaller than the next number, it's going to be half the size, whatever it is, that's what that number is going to be. We call it an exponential function because our x value is the exponent. So that's why it's called an exponential function, because our x value is the exponent. So if our variable there, or that x, is in the exponent, it's always going to be an exponential function. And this is that basic way that we write it. Lastly, we have a quadratic function, and we talked about these quadratic functions. This is this whole chapter. Quadratic functions have a degree of 2, and they make this parabolic or this U shape here. And when we talk about graphing quadratic functions, they have a couple of unique characteristics. Remember that this plus c here is our y-intercept. And then remember, they are centered right here at x equals negative b over 2a. And that line that we're centering at here is called the axis of symmetry. As a quick review there, this point at the bottom is our vertex, but that's kind of how that c, that a, and that b come into play. So we're going to be comparing these linear, exponential, and quadratic functions by looking at them either graphically or by looking at their data in a table to kind of see what happens. So let's start by looking at them graphically. So when we're looking at these questions, we want to plot these points and decide whether they appear to represent a linear, an exponential, or a quadratic function. The easiest way to see that is a linear function will obviously be in a line, an exponential will look like this, and a quadratic will look like this, a U shape, or it might be a frowny face shape. So let's take a look at these 5 points here and kind of plot them on our graph. So here's my graph. My points that I have here are at 4, 4. I've got one at 2, 0. I've got one at 0, 0. I've got one at 1 and negative half. Got one at negative 2, 4. Well, looking at those 5 points, it looks like I can easily draw a line like this, and that looks a lot like a quadratic. Now let's take a look at this next one. See, what do these points look like? And again, we are just plotting these points here to see what happens. So I've got a 0, 1 point right here. Let me do it in blue again. A 0, 1. I've got a 2, 4. I've got a 4, 7. I've got a negative 2, negative 2, and I've got a negative 4, negative 5. Well, those look pretty linear to me, so these ones are going to be linear. Notice how they look like they all line up in about a straight line there. And again, I'm just sketching these graphs. This is just an approximation, but you can kind of tell what each of these functions look like. Okay, now let's check out this third one. So as I graph this third one here, we want to decide, is it a quadratic, is it linear, or is it exponential? So let's take a look at this one. I've got 0, 2, at this point right here. I've got 2, 8, so that's going to be like way up here. I've got 1, 4. I've got negative 1, 1. I've got negative 2 half. Do you see how this one doesn't look symmetric like our first one? But it also isn't a straight line. This is going to create that exponential function that we're looking at. Notice how it slowly gets bigger or gets steeper the further up we go. If it's negative, we also may see an exponential function that goes the other way. Now, these ones that go up, we usually call exponential growth because they're getting bigger. These ones that go down are typically called exponential decay, as they're decaying, or we're getting less of a y value the further we go. And that's kind of that difference between a quadratic, a linear, and an exponential. Now, continuing on with this idea of linear functions, exponential functions, and quadratic functions, it's easy to tell when we graph them. But sometimes we don't have the graph and we just have those points. And it works okay. We can always plot the points. But there's actually another way that we can tell whether a function is linear, exponential, or quadratic. The easiest way to do it is to look at a table of numbers. If the numbers of our y values, so when we say the first differences, we're talking here about our y values. So if I look at a set of y values here, so let me take an example of one from one of these other pages. So let's look at maybe this one right here. Okay, we want to determine whether this one is quadratic, whether it is linear. Let's move it to our next page, right? So we're going to cut this. Let's move it back up and decide which one is it going to be here. So what we're talking about as we look at these, paste that. Okay, here we are. Oof. We want to move it. Okay, so here we are. So what we're talking about is we're looking at the difference in our y values here. And depending on what that difference is, if they're a constant number, then it's going to be a linear function. So as we look at this, does it look like it goes plus 2, plus 2, plus 2? If it looks like we're adding those plus 2, plus 2, plus 2, just like that the first time, then it's a linear function. If it looks like I'm just adding them, the difference is constant. It is going to be an exponential function if they have a common ratio. So what that means is if my y values seem to be multiplying. So right here, how do I get from 1 to 3? Well, 1 to 3 is times 3. And how do I get from 3 to 9? Well, I'm going to multiply it by 3. And how do I get from 9 to 27? Well, I multiply it by 3. 27 to 81 is multiplied by 3. Notice how each of these have this common ratio of being multiplied by 3. Because this one has a common ratio of being multiplied by 3, it's an exponential function. Because that ratio, when we're looking at those differences, goes up. If for some reason we got something different, so say we were looking at, instead of these ones, say we were looking at the numbers 1, 0, 1, 4, and 9. Okay. When we're looking at these, notice the difference here. So we want to look at this first difference. 0 to 1, well, the difference is 1. Right here is 0 to 1, the difference is 1. 0 to 4, the difference is 3. 4 to 9, our difference is 5. Notice how those change that difference, but then we want to look at the differences of these. So the differences of these are 0, 2, 2. If we went to the next one, so 4 would give us a 16 here. This one goes up by 7. The difference here is 2. Do you see how the difference between all of these is 2 right here? Because these all have the same difference, that second difference is a constant, and therefore this is a quadratic equation. So again, as we're trying to decide these ones, if the very first time I look and I say, oh, it's plus 1, plus 1, plus 1, then it's linear. If it's times 2, times 2, times 2, so we're multiplying with this one. If it's multiplying by a constant, then it's exponential. If we are adding a constant, then it's linear. If we are looking at the numbers that we add, so we look at the difference, and then find the difference of our differences, then it's going to be quadratic. So let's take a look and go through a couple of examples like this to see what happens. So let's take a look at this first one and decide if it's linear, exponential, or quadratic. So remember, linear means we add the same number. Exponential means we multiply the same number. Quadratic means we find the difference, and then the difference adds the same number over and over. So the difference has the same difference. Okay, that's kind of what it means. So let's take a look at this first one. How do I go from 11 to 8? Well, I subtract 3. How do I go from 8 to 5? Well, I also subtract 3. How do I go from 5 to 2? Subtract 3. How do I go from 2 to negative 1? I subtract 3. So do you see how I'm adding a negative 3 every time here? So if I'm adding the same constant number, that means that this has to be a linear function. What about this next one? I'm multiplying. I want to look to see if I'm adding the same number, multiplying the same number, or if the differences, if it varies, so it's not adding or multiplying the same number, but then those differences change, then we know what we're looking for. So right here, to go from 1 to 2, well, I can add 1. 2 to 4, I add 2. 4 to 8, I add 4. 8 to 16, I add 8. Okay, so it doesn't seem like it's adding the same thing, but could I try multiplying the same numbers? Well, let's try that. How do I go from 1 to 2? Well, that's times 2. 2 to 4 is times 2. 4 times 2 equals 8. 8 times 2 equals 16. So notice how we're multiplying by that same constant. So that means that this one has to be exponential. And notice how that first time I tried adding them and it didn't work. If I try adding them and they seem to vary, always try to add first and then multiply. And then if it doesn't work, then try finding the difference between those two. Now let's look at this last one down here, this C. So I want to look at the difference of these. Right here, how do I go from negative 1 to negative 2? Well, I subtract 1. How do I go from negative 2 to negative 1? Well, I add 1. And then negative 1 to 2, well, then I'm going to add 3. And then 2 to 7, I have to add 4. Okay, so now let's look at the difference between these numbers. From negative 1 to 1, that's a plus 2. From negative 1 to 3, I add 2. From 3 to, that's not a 4, that's a 5. 2 plus 5 is 7. From 3 to 5, I add 2. So notice how this second tier here is all the same number. We're adding a constant. That makes this one quadratic. So again, we want to check to see what do they add to. If it looks like they add to a second number that's all the same, then it's a quadratic. If not, then see if they all multiply to something and see if it's exponential. But that's how we're going to do these ones, is we're going to test them that way. So let's take a look at that one from our earlier example right here. I want to try adding them. Let's see what they look like when we add them. Let's move them to a new page here. Okay, so here we are. Here's our last example of this kind. So let's find that difference. So right here, 1 to 3, well, I add 2. 3 to 9, well, I add 6. 9 to 27, well, that's going to be plus 18. And then 27 to 81, whoa, that is going to be 81 minus 27 would be 54. Okay, and then I find the difference of these. This would be plus 4. This would be plus 12. This would be, how do I get from 18 to 54? Doing that math, that would end up giving us 36. So notice how this second tier, it didn't work. And this first tier didn't add to the same thing. So I know that it cannot be linear. So it's not linear because that first tier didn't work. It's not quadratic. So I want to check to see, is this one exponential? And the way I'm going to do that is I'm going to check to see if they multiply. So 1 to 3, well, that multiplies by 3. 3 to 9, that multiplies by 3. 9 to 27 is multiplying by 3. And 27 to 81 is multiplying by 3. So this one has to be that exponential. So that's how we're going to determine it that way. The last one that I want to cover, just very briefly, using this table, let's decide if it's linear, exponential, or quadratic. And then based on that information, we want to write the function. So let's take a look at it and see what happens. Remember, we can write a function if we're given the slope and the y-intercept. We can do it if we're given the y-intercept, and the change in numbers. We've got lots of options here. So let's take a look. How do we go from 12 to 0? Well, that's going to be minus 12. To go from 0 to 4 is minus 4. From 4 to 0 is plus 4. And from 0 to 12 is plus 12. Okay, now let's look at those second differences because it's obviously not linear. So now let's look at our second differences. Negative 12 to 4, well, that's plus 8. Negative 4 to positive 4, that's plus 8. And 4 to 12, well, that's plus 8. So notice how these are all plus 8. So this means we have a quadratic. So now we want to write a quadratic based on the numbers that we know. So there's two ways we can write this quadratic. One thing that I notice here is I notice that I have these two zeros. So when y equals 0 or f of x equals 0, x equals both 1 and 3. So that tells me when I'm graphing this. So imagine we graph this. Here at 0, I'd be all the way up at 12. At 0, I'd be over 1 here. And then at 2, I'd be down at negative 4. And then at 3, I'd be up here. And at 4, I'd be all the way back up at 12, right? So this tells me a couple things. It tells me my vertex is this number right here. This is my vertex. And it tells me that these are two of my points. So I kind of have two options on how I want to write this. To me, one of the ways that we can do it is if we're given our vertex, let's do it using vertex form. That makes it super easy. So vertex form, remember, is going to be f of x equals a times x minus our x values, so minus 2 squared minus 4. Now I need to figure out what this a is. The easiest way to figure out that a is to use another point and solve for a. So let's use this point 1, 0. So I'm going to put 0 in here. I'm going to put 1 in for x. So a is 1 minus 2 squared minus 4. So 0 equals a times negative 1 squared minus 4. 0 equals a times 1 minus 4. Well, 0 equals a minus 4. So a equals 4. And that's pretty easy to see because we can tell that as we're here at this negative 4, as I go over 1, I went up 4. So this means that our quadratic and our equation is f of x equals 4 x minus 2 squared minus 4. And that is how we would write it. So you can either look at your equation here and figure out if I go over 1, I go up 4, and that's how we get this 4 here, or you can substitute a point in and solve for a. Either of those two options will work great when we're writing our function, but that is basically how we tell the difference between a linear, an exponential, or quadratic function. So remember, if we're graphing them, linear is a straight line, exponential goes up faster or down, and then a quadratic makes that U shape. If we're given a pattern that we have to observe, a linear function, as we go from the first one to the next numbers, we're adding something here. If it is an exponential function, we are going to multiply something between each of these. And if it is a quadratic function, we are going to find the difference. So I'm going to subtract, 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 and then find the difference between these ones. And depending on what those differences are, that will determine if those are the same difference, and then it'll be a quadratic. And that, in a nutshell, is how we decide if a function is exponential, linear, or quadratic.